Welcome, everybody. Welcome to another live stream with Intelligent Construction Opportunities. Intelligent Construction Opportunities does these live streams so construction technology providers, like our guest today, can show off the value of their software and technologies for construction professionals. Our objective is to help the construction industry understand the transformative offerings provided by these technology providers. And if you would want to show off your own construction technology, contact Intelligent Construction Opportunities at info@intelops.com, and we'll have a deep and wide discussion about what it is that you are bringing to today's construction professional. Today, we welcome Icaro Mariani, the Engineering Solutions Manager at Giatec Scientific from Ottawa, Canada. Welcome, Icaro.
Thank you, Stephanie. It's a pleasure to be here with you.
It's very good. We've been doing a lot of planning behind the scenes to prepare for today, and very excited to dig deep into a really vital part of all construction, concrete, and to really understand some of the more important pieces of technology that align with such a fundamental contribution in terms of a material for any and most construction sites today. So as we're getting into this and getting to know you, Carol, can you share a highlight about your own experience working with Giatec and tell us a little bit more about Giatec? And then I'm going to run a little video that we have so that our audience can sort of be opened up to the whole area of what we're discussing today.
It's really hard to narrow down to one. I had such amazing experiences in 5 years at Giatec. But if I were to mention one, is like we had a massive visit in Turkey back in June this year, where we actually leveraged our technology to different Turkish contractors and worldwide contractors, including North American ones. And we saw how even there, our technology was already fairly recognized, and a lot of people knew about us, and they actually deployed our sensors in different projects over there. So it was amazing to see how we're helping to reshape the current state of technology in the construction industry.
Very good. And do you do a lot of traveling all over the world now, Carol? Because Giatec is global.
Yeah, so it depends. So we have a worldwide presence. We have assets in Japan, in Jordan, in the Middle East, and specifically in Dubai. We also have in South Africa, the UK. So we have a global presence, also in Latin America. So I would say we travel depending on the importance of given projects, but we have different Giatec employees strategically located worldwide.
Very good, very good. And so how many countries are you in now? Do you know?
We have projects in more than 80 countries right now, and with above 13,000 projects using the Giatec SmartRock technology.
That's amazing. 13,000 projects. Good on Giatec. Well, I think what we're going to do is help the audience. Anybody has any questions or comments, by all means, interject throughout today's conversation with Carol. But for now, what I'd like to do is I'd like to show a little video that Giatec has produced that I think very much summarizes the good that they're doing in the world in the construction industry. So let's go ahead and take a look at that. good. Very good. So it's interesting. I just noticed something I hadn't noticed before, and that's some name of Roxy. So you'll have to share with us how Roxy and SmartRock and sort of the whole idea of the system. So I want to know. Let's just sort of jump in here. Uh, Obviously, Giatec space is concrete, and with the environment and all the issues around concrete, what do you see as the biggest challenges currently facing the construction industry as they relate to Geotech and what you've produced here in technology?
I would say there are so many challenges that we face right now in the construction industry, but one of the main ones is the lack of visibility most contractors and even concrete producers they observe when they are trying to understand the quality of the concrete. So, for example, right now, worldwide, we rely on concrete samples, either cured in the field or in the lab, to estimate your strength. And the specimens, either cylinders or cubes, depending on where you are, they do not provide the full visibility of what is going on inside your concrete. The curing condition is different, the ambient condition is different, the hydration process is also going to be different. So right now we see that we need to do better. And by using sensors that can actually track the in-place strength, temperature, and I'm going to talk about our newest addition to the family, the SmartRock Pro. You can actually capture in reality what is going on in your structure and actually take more decisive and precise decisions on your project schedule.
Well, we already have a comment, as a matter of fact, from Najib Drabu, who says, once you start pouring the concrete, is there any effect on the device?
So that is a really nice question. So that ties to Roxy. The sensors that you saw in the video, those are the SmartRock 3 sensors.
Yeah.
They activate when you pull that, and they start making a reading every 15 minutes. Okay, so every 15 minutes, you're getting a reading both inside this body and at the cable. So to mitigate and actually bring more precision to contractors, we have Roxy to identify when concrete is actually touching that probe through the sudden change in temperature from, let's say, let's talk in Fahrenheit. Let's imagine it's 40 degrees Fahrenheit outside. Concrete touches it at 72. What's going to happen? You're going to see that sudden change in temperature. So the sensor knows that that is your time of pour. Additionally, we can verify this through machine learning. Sorry, through the hydration process, Roxy can really pinpoint. Okay, this is where your hydration process begun, so you can actually pinpoint when the pouring time started. So yes, you're going to start referring to your strength gain over time based on when the concrete touched the probe. If that makes sense.
So it sounds to me like there's an interactive component in here. So as you're doing it, you are adjusting perhaps on Roxy's recommendations. Do I have that right?
So the power remains with the user. So the user is the source of truth. So the user is going to be the one telling the sensor, okay, my pouring time was, I don't know, August 2nd at 2:55 p.m. Okay. But if that is off from what Roxy think it is, she can actually suggest a different approach. From what I'm seeing in your concrete, your pouring time is actually 1:59 p.m. and not 2:26.
So
But
this
yeah.
leads me to my next question then. Who are SmartRock's, in this case, SmartRock's typical direct and indirect users?
Um, I would say the most common user would be general contractors. Okay, so we're talking about the field engineers, the project managers, QC personnel that want to verify the quality and like the state of the concrete over time, especially in early ages. But you also have testing agencies using SmartRock sensors a lot, and even concrete producers. So we have major producer partners across North America and worldwide as well that leverage the SmartRock technology to bring that level of confidence and more accuracy to their customers.
So give us an idea. So let's take a field engineer, for example. You've just onboarded the company, and they're all excited about using SmartRock. So take us through kind of a day in a life of how and when they might implement that using their own, because of their own role as a field engineer.
Before I answer that, let's just make a 20-second recap of what would have been if they would not use SmartRock, right? The
Okay.
goal is to replace the field samples, the ones that are telling you when to remove forms, when to stress cables on postation decks, even opening pavement to traffic, right? What they would have done is call the testing agency, cast the samples, testing agency returns the next day, pick up those samples and break at 2 days, 3 days, or whatever your target is. Project manager waits for the call or for the report. Okay, I'm good to go. And then they move on with their schedule, with their operations. What changes with SmartRock is instead of doing that, they're going to tag a sensor. Of course, it needs a calibration, and we can talk about that. But after the calibration to the sensor is done, they're going to tag the sensor as you saw in the video. They're going to install the sensor no more than 2 inches from the surface. This tail here, this white tail can go anywhere. So we have different length. And then you pour your concrete. So what you can do is you download the data an hour after, a day after, or close to when you typically need to move on, and see the data right away on your phone. Not only you, anyone that you invited to have visibility in your company in that project. You can set alerts. Let's say your target is 3,000 psi, or let's say in metric 20 MPa. You're gonna know when you reach that strength, and then you can move on. You can remove and flip your forms to fly them over to the next deck. You can stress your cables so you can have that post stationing happening within a reasonable time frame. That is the biggest difference. You don't need to wait for that call to move on.
Are you using any particular integrations with that?
We have integrations. We have like an open API, so we can integrate with pretty much any software, any construction management system. We have a direct integration with Procore. So you can have the reports automatically integrated with your Procore account, but we can do with other softwares as well.
Well, here's Najib again with another good question. It's indeed a game changer in construction, but he wants to know how precise are the results? Do you have a data sheet on the same?
I can definitely share, but the results are gonna be as precise as the mix consistency is maintained throughout a given period. So the the sensors they rely on what we call the maturity method, and the first assumption of the maturity method is that your mix is not change or not changing or not drastically changing. If you have a mix that perhaps is drivers are adding water at the job site and you have a constant variation, then you're gonna have something that is not that precise. Now, if you have a standard process where the mix is very consistent, uh, the precision we're talking about is plus or minus 10%, which is per ASTM C1074.
I hope that answers Najib's question. I think we could provide some data sheet after our call today. We'll take this offline and see what we can do to provide our listeners today. Najib, I want to thank you. That's a really good question. We have another question by a good colleague of mine, Renee Glendenning, who is big in the area of quality control. And Renee is asking, what is the lifespan on your devices? Concrete can be hard on instruments. Good question, Renee.
Excellent question. So as long as you do not store the devices out there in minus 30, they don't have a shelf life. But in terms of when you install them, the sensor has a battery life up to 4 months and a memory of 2 months. As they are designed to capture the early age strength, we're not focusing at 28 days or 56 days. So they are sacrificial instruments that are fully embedded into concrete, but they're going to provide you that real-time data up to 2 months after you install them.
Okay, and so because intelligent construction opportunities tries to tease out the real context of these devices, can you share some specific construction projects, no matter whether residential, commercial, industrial, and whatever it is? You brought up that being in Turkey at the top of our at top of our show today, can you share some examples that really come to mind that you think are real standouts in terms of having changed the situation because of SmartRock?
We have multiple projects worldwide. Like I can pinpoint several, perhaps thousands of projects here. But thinking about here in our backyard is the LRT project, right? We have sensors deployed there. They have what we call travelers. It's a cutting cover segment where you have this massive, I think, is a $2 billion project, and they need to move on the traveler to keep on. And you can only move that traveler after you achieve a specific strength. So you install sensors over there with what we call a LoRa gateway smart hub. Basically, the sensors can also interact with a modem at the job site that we provide. And
Okay.
instead of you downloading the data out of the sensors, that is automatic and then goes to the cloud. So everyone in that project knows when the traveler can move on. So this same principle can be applied to a high-rise building. So we had a massive building, uh, let's say, I believe that was in Indiana, that they were using the sensors, high-rise building, and they were able to flip forms and keep on moving with the project because they knew they had the necessary strength.
Very good. Well, here's Renee again with another question. And I've got, some certainly people in my network that would also enjoy an answer to this question. Have they been used on any federal projects such as the Corps of Engineers or, any of the government projects here in Canada?
Yeah, so they were. I cannot disclose the name of one particular project that we are starting right now,
Very
but
good.
the sensors were used actually like in a nuclear waste facility in New Mexico. And I know that the restrictions are high, so we need to really make sure that the sensors are compliant with a, a different set of standards, not only STM C1074. So yes, in a nutshell, we use our sensors in locks, in dams, in nuclear waste facilities, in water treatment facilities, and actually army facilities as well, if that answered your question.
I hope that answers it. It certainly, it tells us, yes, that there's worldwide coverage in any kind of a building, let alone, to your very point, the privacy required of federal entities. So Najib is asking another question. Do these devices work well in hard temperatures? Is temperature going to be a constraint in performing efficiently?
Yeah, so the sensors they're going to perform well for even temperatures in mass concrete. So when you talk about mass concrete, even let's say a grout mix where you have like a spike in temperature. So we're talking about 80 up to 85 degrees Celsius. We're talking about 180 Fahrenheit. If you go above that, it's not that the sensors are not going to read. We cannot keep on with the accuracy we promise. So our accuracy is up to plus or minus 1 degree Celsius or 1.8 Fahrenheit, up to 85 degrees Celsius. Above that, the sensor is still going to read, but that accuracy is going to jump to 3 degrees Fahrenheit, more or less.
Okay. Okay.
But if you intend to install it in a non-concrete application, I don't know if you're inducing temperatures such as 200 degrees Celsius, that is not the solution for you.
Well, it's good to know. It's good to know that there are boundaries, that
Mhm.
I mean, if you're going to be good in the situations you are, every situation has its limit. So I think that's very good. And an add-on in performing efficiently, he meant as opposed to performing constrained performing. Can't even see the difference there, Najib. Anyway, we'll move on. But I want to sort of continue on with this idea of integration because technology in construction keeps evolving, and more entities have what we call on the tech side a stack. And so I'm curious to know, you mentioned that you do have an integration with Procore. Do you also integrate in some way, shape, or form with things like drones that are more, you know, I'll say less software?
Um, Jones, no.
Oh, drones, drones,
Sorry, can
drones.
you repeat it? Jones.
Drones, like the flying drones.
Yeah, so we don't. I'm not gonna say that we never considered it, but our goal is to really install the sensors inside your element and track what is going on within that element, right? And drones, they are gonna basically provide you a different set of perspective, a different perspective. Let's say you can have drones to map up um, a given bridge and tell you if that crack is from delayed extrinsic formation or is that just I don't know, plaster shrinkage. So that is a different technology that we are not pursuing right now.
A more high level as opposed to the precision that you're trying to get with SmartRock on the ground. Is that fair?
Yeah, I would say
Yeah.
100%, yes. But we do have other devices. It's not part of our flagship product. Our flagship product is the SmartRock, but we have devices that can measure corrosion rate inside your element. So let's say bridges and other structural elements to assess durability. Uh, and
And
we're actually very proud of that device.
without going too far away from SmartRock, what would those use cases be?
For example, post-mortem, let's say the collapse of the buildings in Florida, I believe it was last year or 2 years ago, they were used there, or even to check the service life of a given bridge or a given structure, let's say a garage. You can use the device to see if the rebars are corroding, measure that corrosion rate, and check, okay, for how long will that structure still survive without making any intervention right now.
Very good. Very. I mean, I think it's great to know because I really feel that the power of SmartRock is one thing, but as an entity, Giatec, you really are understanding what your space is and where your expansion can be. So I want to kind of move on. How applicable is SmartRock for small projects versus large and complex ones, which I think it's fair to say that is understood.
Um, I would say it depends on what you consider small or large, right? So a small, if we're talking about housing, let's say regular townhomes, and I would say that the smart rock sensors can be used, but perhaps they're not as beneficial as they would be in a high rise. The goal is when you're using the sensors to shave off schedule, right? That's one of the main goals. So
Okay.
if you want to shave off schedule, you need to have a target that you're waiting for the concrete to achieve before moving on, right? Mainly if you have, a house that you're building, when you're building the foundation, which is where you typically use the concrete on, you don't have that target very early at 3 days or 7 days. So perhaps the sensor is not best applicable there. However, in large projects, even, high rises or even, infrastructure projects, strength might not be the only thing that you want to track. Temperature is also a thing. So you need to obey certain temperature limits, especially differentials between core and surface, to make sure that you are within the parameters. The smart rock can actually tell you, okay, you're almost at your limit. Go back and put tarps on or put blankets on, so you can ensure that you're going to meet your durability requirements.
And so when we're talking about smaller projects, what are you? I mean, obviously you're in 80 countries. What would you say is the average number of projects that your type of client is running? Just to make a distinguish for the audience so they understand. Okay, well, if you may be a small residential housing builder, but you don't put up any more than two major subdivisions in a year or something.
So it varies a lot. It's really hard to pinpoint, and I will need to dig in to provide you with a more accurate answer on this. But I
Okay.
would say a lot of places where the sensors are deployed are on high-rise buildings, on hospitals, on office buildings. So not even 10-story buildings. In a 4-story building, perhaps that is what you're aiming for, so you can move on because you have a large square footage area, right? Um, Stadiums, theaters, the sensors can also be used on podium decks. So uh, I would say almost the sky is the limit here because there are so many applications to it. But the average project size, I would prefer to get back to you other than providing you with like an
Okay.
inaccurate
All
answer
right. Well,
here.
can we put it a little differently? And I don't need you to if first of all you can say, we can talk about this offline as well. But when we're talking about a basic entry point price range for SmartRock, is there a range that you can address or not?
That depends on region to region, right? Because we have different pricing models for bulk orders, or what type of solution you're going with. Let's say the same smart truck that is going to provide you like readings on your phone can also interact with a gateway and provide you remote monitoring. So the pricing model changes from a project to project and region to region depending on what you need. So that is mainly with our sales team, but yeah, I cannot pinpoint like a unit price right here, but message us and we can discuss about it.
That's fair. That's fair. And we do have somebody asking about that, and so we will address that and follow up specifically. And perhaps maybe even, I want the audience to know. I mean, um, this is not about I don't know what I'm trying to say, a direct sale. This is about educating our audience, letting people know that this kind of a monitor exists, and then it's between people to have a conversation about, does it work? Who's it for? These very details. So we don't want to shy away, and we'll get to how you can contact these individuals at the end of our live stream today. But by all means, we want to keep the conversation going, and the answers are in the details.
I would just like to add one thing here. If it's feasible for small contractors, yeah, it is 100%. Because the price we're discussing here is not something extraordinary, okay? But the benefit you get out of this, outpays it a lot. So, like, while you can get the benefit in not only increasing your durability but shaving off your schedule, it pays it off by, you know, a lot.
And that's important because most people make business investments for some kind of return, so that goes with the territory. So while I'm looking at a couple other comments here, can you demonstrate or show a little bit about, you did show the sensor earlier,
Mhm.
but maybe this is a good time to, this is, so we're calling this a mobile interface. I mean, this is part of the SmartRock system. It has nothing to do with whether it's mobile or not, correct?
Yeah, so this is the hardware portion of it, and our greatest differential is all the analysis you can take out of this. So you can install multiple sensors in a job site, tracking different pores. They can actually tell you how those different sensors are behaving, right? So all the data, it goes to the phone and then the cloud, or from the smart hub to the cloud. The cloud itself is where you can analyze multiple sensors at a time, mass print reports, and take decisions on. So that's where you're going to see your thresholds, your temperature, your strength over time, and actually take decision. So that's where you're actually going to, uh, I would say, build your reports and build your analysis that are so important to your project schedule, even for temperature differential analysis, to see if you have achieved something that is greater than permitted, or if you need to take action before you achieve something.
Okay. And so Aditi's asking, can you share some tips for pre-pour planning before the cold weather? Since that's, well, for most of us in North America, that's something on the near horizon.
Yeah, there are many things you can do beforehand for cold weather, such as making sure you have the heaters on. If you have diesel heaters in an infrastructure project, you need to make sure they are all working and functioning. But it pertaining to our technology itself, in the tips I would recommend is tagging the sensor beforehand, installing them in the critical locations, and as I mentioned, the body of the sensor needs to be placed within the 2 inches mark, right? So especially for cold weather conditions, you're losing heat from your surface. So that body here is telling you your weakest point in your home. So during cold weather, we see a little bit of a shift in the use of the sensors. They're
Hmm.
also used for shaving off schedule and time savings. but they're also used as a safety net. You can use the sensors to actually confirm that you actually have enough strength, because your samples are going to a lab in an ideal environment at 20 degrees Celsius or 70 degrees, 100% humidity. So they're perfectly warm there where your structure is suffering, right? So you use the sensors to actually mitigate and be sure that you have enough strength to go on.
Okay, I hope that answers the question for the audience and for Aditi. Najib is asking again, are these devices cost effective also in comparison to field lab tests? I think, well, you go ahead and answer that question.
100%. 100%, especially when you have the field samples, because if you do it correctly, your field samples, let's say you leave 3 samples on site right next to the structure, you need to move them 15 minutes, up to 15 minutes after you cast them, right? If you cast them on, close to the pumping or close to the pump, you need to move them on to this story where they're going to be kept on. And then you need to get those samples 2 days or 3 days later, break them. And if you don't have enough strength, you need to break another one. That is another trip to the project. So I would say even the break versus the cost of the sensors, they're fairly reasonable.
So I'm going to take your average, I guess maybe not a field engineer, but somebody who's not of an engineering background. How intuitive is it for the average field personnel less familiar with technology to be able to start to get the full function out of SmartRock? And what training and support do you provide?
So excellent question. We designed the product to be as intuitive as possible. So the box itself comes with like the installation practices in 10 easy steps, which is basically download the app, tag the sensor, turn it on, install it on the rebar, and guide this tail or whatever you want to have as a secondary point of measurement. Because as I told you, we have 2 points, right?
Mm-hmm.
Um, but for massive projects where you really want to know, okay, what are the best locations that I want to install my sensors? We provide full onboarding training and support to everyone purchasing sensors. If you purchase 10 sensors and if you purchase 1,000, the support team is always going to be there to help you. And like in different time zones, as I told you, we have people in Japan to
Yeah.
cover the Pacific coast as well. So even in California, 5 p.m., we have someone answering the call to support. So they're designed to be as intuitive as possible, but we also provide this full onboarding session.
Very good. So I'm curious, and maybe I have this wrong, but does SmartRock or it provide any issue around? I believe there's a biometric functionality, and is that correct?
They don't like you to activate using your, let's say, your digital or like that's what you're talking about,
Yes.
right?
Yes.
No, they don't, but the way we protect the data is you need a login and password,
Okay.
okay? And in the app to access the information, and you have every company has different role permissions. So you can have someone that is only able to download the data out of the sensors, cannot do anything more than that. You can have people that can only view the data but not do anything. And then you have admins that have full permissions under that given project. So you can only see the data and the strength if you were invited to that company where those sensors are being deployed.
Good. And that I mean that tends to be par for the course for most SaaS offerings, but it's good to know because sometimes when you see a piece of hardware, you miss that idea that may be more obvious and prevalent in software. So I wanted to switch gears a little bit. And this is a little bit going around the environment question, but does SmartRock help construction companies stay compliant with industry regulations and standards? What kind of things do you sort of, I don't know, build into that idea with SmartRock?
100%. So we actually like to stay ahead of the game. So the Canadian standard was the first one to account for what we call um, performance-based temperature differential limit. So for mass concrete applications, most projects in North America, they were sticking to a maximum differential of 20 between core and surface. I'm just bringing an example, by the way. Uh, we built the temperature differential analysis in our system to account for this. Okay, so you can see how that is progressing. What happens is now you can, depending on your thermal control plan, boost your differential to 25 or 30 degrees Celsius or 35, 45 degrees Fahrenheit based on your strength. So we not only comply with their requirements, but we try to stay ahead of the game. If something is being studied to be placed as a review in any code or recommendation, we want to be sure we comply with that. And that's what happened with the Canadian review that was later implemented in 2021 to ACI 207, Guide for Mass Concrete. So you were kind of already, okay, adherent to that.
And I would imagine, I mean, now you'll tell me, but you have quality control teams, I would imagine, because you're in 80 different countries. I mean, obviously, you just gave a Canadian example, but you must obviously be able to, be ahead of the game in terms of the regulations, for example, in the US, where I think, a large number of our audience is probably coming from today.
Yes, yes. And what it was, when we saw a change in the Canadian code, we saw there was a movement happening in ACI, the American Concrete Institute, right? That's why, and right now it's an ACI. But I would like to reinforce that the most famous standard for maturity is ASTM C1074. So folks worldwide, they refer back to the American standard if they want to use maturity, not only if we are with our system, any maturity system. So we are completely compliant with that. More because the minimum requirement is readings every 30 minutes. We make readings every 15. So we are more than compliant with the standard.
Good on Giatec and SmartRock. So you touched on some data before. What types of other data and analytics does SmartRock provide, and how can the back office management use these insights in your average contracting company to improve their future project performance?
We have not only the data from the SmartRock, we can predict how your concrete is going to behave with thermal modeling. So instead of purchasing a very expensive thermal model system, you can actually select the location of your project, the size of your element. I want to reinforce this is mainly for mass concrete application, such as this column behind me. But
Okay.
you can actually mimic how your concrete is going to behave, given your mix design, your mix proportions, your location, and element dimensions, and even blankets, type of form. And what you can do is, okay, I'm probably going to exceed my thermal control plan requirements. So you can actually go back to your design, talk to your producer, add ice to the element, to the mix design, or purchase blankets beforehand. So we provide different solutions that come with the purchase of one sensor or 1,000 sensors. So we really like to offer something that is really going to reshape the status quo of what we observe in construction.
It would be good. I think we'll take this offline, but I'd love to see some documentation and reporting that comes out of having the sensors and to be able to share those with the audience. I think that would be very valuable. And speaking again of the audience, as we sort of wind around the clock here to our, well, generally speaking, between 40 and 45 minutes, can you share some other success stories? You've got some pretty heavy hitting names on the website that are already doing business here in North America with Giatec. So I know we gave some examples before, but maybe ones that you're a little more intimately involved with that you would know are saving, either the labor challenges or time, whatever it is that you think, is another example. I like the one in Turkey. Um, I had a colleague in Turkey, and I knew that they built almost 100% of their projects using some form of concrete. So what comes to mind for you, Carol, to share with the audience?
So many projects, but comes to mind. I can mention the Rundout project in New York. We had over 1,000 sensors deployed there. Shotcrete application. The sensors are able to tell you that you were reaching 500 psi on the Shotcrete application. So even for Shotcrete, it can be useful. Also, the Ambassador Bridge in Michigan. It's a massive one that
Well,
we had remote monitoring happening over there. Uh, Hundreds and hundreds of sensors were used in that application. Um, Bridge projects we had, let me think, the BSCGP project in Vancouver. Okay, it's a massive undertaking by Broadway Subway Project there. The sensors are currently being deployed in that project. If you reach out separately as well, individually, I can list uh, different contractors and different projects in North America specifically that the sensors are being deployed.
that would be wonderful. That would be absolutely wonderful. But you're making me think of, I mean, you hear so much in the news now of problems with bridges. I mean, let alone the one that happened in Baltimore, that accident, and all the tragedy around that. And that's a rabbit hole we could go down, but I won't. Um, but I mean, just how vital this kind of technology is. We've got another question from Najib. How do you come to know if the device is malfunctioning or displaying wrong readings, and what measures does your quality control team take to keep that in check?
Excellent question. So we try as much as possible to have a device that is rugged enough to survive job site conditions. Okay. I can tell you that our failure rate is way below 1%. So we're talking about zero point 0.1 to 0.2%. But what I can tell you is the sensors, they take two different readings, right? Cable and body. So if eventually a vibrator damages the cable into a certain level that is not accurate enough, you're going to see that in your chart. You're going to be able to pinpoint the time that your cable snapped because the readings are not going to be consistent. And the way you can confirm that the sensor actually was damaged is you see that the body readings, the logger ones, are fine, and the cable readings aren't. So that is the way we can identify when something went wrong on the job site. I hope that makes sense.
Good, good. And Najib has another question. How do you avoid the displacement of this device during shot creating? So um, I'm interpreting what he's asking, but it is a device after all, and it looks like it's small enough to go missing.
Yeah, so it all depends on the nozzle person, right? If the nozzle person is shot creating and providing a cover that is greater than 2 inches, you might lose that signal out of the body. So what we recommend is tie the cable to the mesh. So for shotcrete specifically, uh, in that application in the Roundout project, they had wire meshes that you were shot creating onto. So we're able to tie with zip ties the cable and the body. So we had a longer cable. So the tail would go up 10 feet and then the body would be on the side. So that's the way we're able to prevent it from being displaced even during shotcrete.
Good, good, very
Yeah.
good to know. And I mean, obviously, I mean, you're dealing with such a dynamic material. You would have to have built in what I'll call the downside of having losing this kind of device on the job. So it's great that it's been put into your whole process and your onboarding of using it. I want to sort of wrap up now and sort of talk a little bit about what's on the roadmap and what's future and down the road. You did show me a little earlier the new I'll say the new kid on the block in Giatec. Do you want to show us and talk a little bit more about that?
Yeah, 100%. So this is the sensor you're referring to. We call them SmartRock Pro. This is the newest addition to the family. So this sensor can actually capture your strength and measure your strength with no calibration. The first one, the SmartRock 3, it needs a calibration based on the maturity method. So you need to cast samples, correlate temperature history, immaturity versus breaks, and then the sensors can be used. This sensor over here has two main components, and I can quickly show to you. We have the antenna, which is this one. My apologies. This one. This is the antenna, and I think I'm going to remove my background effect. And my
Yep.
apologies.
No, that's fine. And actually, if we could even we could remove your name, that would also give us a little more space.
Okay, okay. So I'm going to remove
Yeah,
this,
a little better.
this, save. I think I need to keep my name on. But basically, this sensor, it doesn't need a calibration. It's what we call a self-calibrating sensor, which is pretty cool, by the way. We actually launched this sensor at World of Concrete this year. We have an early adopter program that is in place right now for people to start seeing how well the sensor performs. I'm just removing. Okay, you
Yeah,
probably can see me.
you can see much better, much better.
Yeah.
Thank you.
So what this tells you, this is the antenna, and this is the sensor that is going to be placed in your concrete. So we need to make sure that you have concrete surrounding those metal plates. And this I cannot disclose because it's a pending patent technology.
Mhm.
Basically, it doesn't rely only on temperature to calculate your strength. So imagine this, you can actually track different points in your element. Let's say close to the highest bending moment, close to the anchor location on a PT deck, or even in a tilt-up application, you can actually see how your strength is performing independent of the mix. So if your mix has changed in the batch plant, this sensor is going to actually see how that mix is performing.
Mm,
Pretty cool.
good, very good. So, what does that do with the current version of SmartRock? Um, does it enhance it? Tell us a little bit more about how that works.
So this sensor doesn't have a standard to obey to, right? To be compliant with, because this is a revolutionizing technology. We call it CEMA. CEMA. Um, uh, CEMMA. Um, it doesn't replace the SmartRock 3 because the SmartRock 3 are fully compliant with ASTM C1074.
Okay.
So this one doesn't follow a specific standard. It's a patent pending technology that we are launching. So they can be used in conjunction. So if you want to have a sensor to comply with a standard and add another one for peace of mind in case your mix has changed, you can actually install those sensors as well.
Very good. Very good. I'm very intrigued by the whole beta testing part of it. So, is there anything else that you would like to impart to the audience before we wind up today's live stream?
Yeah, I would just like to mention that what we have here in terms of hardware sensors is not only what Giatec does. We also have a product called SmartMix, focused for on producer partners. And what it does, it helps different Concur producers to enhance their mixes through machine learning. So Roxy, the one that is implemented on identifying the pouring time, it can actually learn from different mix designs and see if you're overperforming, underperforming, and propose optimizations. So our goal is really not only reshaping and saving you money, but we also want to be sure that we are reducing the carbon footprint. The sensors can help you with that as well because you're going to enhance your mix design. But Roxy can really take off a lot of cement out of mix designs and keep on consistency through different models that are going to allow producers to provide the same quality mix with a lower cost and lower carbon footprint.
So, as a next step, I would like to invite the audience to consider having demos, and I would assume that there is some sort of a demonstration environment that they are taken into. So, as far as for more information about Giatec and in particular the Smart Rock sensor device, you can reach out to Icaro directly, or even better yet, Evan Dudley, Director of North American Sales, who would be more than happy to give you a more thorough and custom introduction to this particular sensor and how it's really going to help your projects. I mean, you really do have some significant, what I would call heavy hitters in construction already using the system. So I think it's really vital that, people understand that it's true and tried. I mean, that McCarthy's of the world and DPR and Scanza already have wrapped their arms around this technology. And as we all know, as the environment continues to shake us all up, all of us when we least expect it, no matter where we live, this whole issue of monitoring temperature is certainly not going to go away. And I think we've got one more comment from Najib. He's saying thanks for your valuable insights, Icaro, but would be great if you could share a compiled present PowerPoint presentation for your next live session. Najib, just so you know, part of these live streams is to be conversational, but we do, when it permits, have our guests provide data sheets, PDFs, what have you after. So don't worry about that. That will be forthcoming. So thank you, Najib, for your own comments. Renee, as always, it's terrific having you on our live streams and interested from a quality control perspective always. And anybody else who didn't comment but was listening today, we thank you for your time. And Carol, we'll see you on the other side. Thank you very much for your time. To me, terrific insights for something that is obviously very science-based. To some might seem boring, but as construction professionals, we all know how just essential this kind of technology is to our industry. So thank you.
Thank you, Stephanie. Thanks for the opportunity of being here, and thank you to everyone that attended.
And we'll see you on the other side. Thank you, everybody. Have a good evening.